What people heard, a headline whisper. It moved like a breeze across a quiet room, the kind of breeze that gently lifts the corners of abandoned newspapers and lets them settle again without noise, as if afraid to disturb the world too deeply. People saw the headline glowing faintly on their screens, not loud, not urgent, but carrying that soft magnetism of something strange, something older than what should be allowed to exist. They leaned closer, not out of fear, but out of that slow curiosity that grows when night is quiet and the heart is unhurried, ready to listen to a story that folds itself gently into the mind. It drifted from person to person, reshaping itself slightly the way whispers do when passed through calm, thoughtful rooms. The idea of discovering something older than the Big Bang felt impossible, yet the impossibility did not frighten anyone. It wrapped itself around them like a warm blanket of mystery. The more they read, the more the hum of the universe seemed to soften, as though space itself were exhaling a story it had held for too long. And as they allowed the quiet to deepen, the whisper seemed less like news and more like a lullaby from somewhere far beyond. People imagined the James Webb Space Telescope floating through a sea of cosmic dark, its golden mirrors like petals unfurled toward an unreachable dawn. They pictured it listening, not with urgency but with patience older than memory, waiting for the faintest ancient echo. The story suggested that the telescope had brushed against something that refused to fit neatly within the cosmic timeline we learned in childhood. And somehow, that mismatch didn't spark chaos, it sparked a slow, dreamy wonder, like discovering a forgotten melody humming beneath the world's noise. As the whisper spread, nights grew quieter for those who carried it. They found themselves looking up at the sky with softer eyes, letting their gaze linger longer than usual on faint stars trembling above the horizon. The thought of something older than the Big Bang was less about contradiction and more about an invitation, a gentle nudge to realize that even the universe, vast and incomprehensible, may still hold secrets it has not yet decided how to tell us. In that realization, listeners felt a peaceful weight settle within them. Some imagined the early universe not as a sudden burst of brilliance but as a long, slow unfolding, like a lantern being lit in the deepest cave of existence. They pictured light, stretching out like a sigh, reaching for meaning while drifting through the silence between newborn galaxies. The headline whisper didn't claim answers, it simply rested beside them, like a story told by someone who hasn't finished remembering all the details but speaks softly anyway, because the act of telling is what keeps the night serene. Others found themselves pondering the idea that time, as we measure it, may be nothing more than a fragile thread we use to stitch our understanding together. The whisper suggested that somewhere far away, beyond the reach of ordinary light, something had been glowing long before the cosmic clock began ticking. It didn't overturn their world. It simply made the edges of reality feel a little more flexible, like pages of a book that can bend but never break, turning smoothly under gentle fingers. The more people thought about it, the more they realized how soothing it felt to imagine a universe older than its own beginning. The paradox became a pillow for the mind, soft and cool, inviting them to rest against possibilities they might never fully grasp. The headline whisper carried hints of ancient structures, faint galaxies, perhaps, or signatures of matter arranged in ways that suggested a story predating the story we know. And each listener, in their private quiet, allowed that mystery to rock them like a cradle suspended between stars. Reading deeper into the whisper, they felt the idea of cosmic boundaries loosen, like knots untangling in the soft lamplight of a late evening room. It wasn't dramatic or urgent. It was subtle, patient, inviting them to drift away from rigid explanations and into the open waters of what if. The universe, after all, had never asked to be simple. And now, wrapped in the gentle hush of the headline, it felt more alive, more ancient, and more serene than anyone had expected. Even scientists who normally spoke in crisp equations found themselves speaking a little more softly when discussing it. They talked about early light, about surprising patterns, about signals that seemed to echo from a time that shouldn't exist. But their voices slowed, as though they were afraid that raising them might scare away the fragile possibilities emerging from the cosmic dark. And listeners, hearing that softness, drifted further into the hush, letting their minds float freely. People pictured the Webb telescope staring into a region of space so faint, so distant, it felt like a memory the universe had almost forgotten. The idea that something could linger from before the Big Bang made them imagine time not as a line but as a vast, swirling river where eddies can hold ancient currents alongside new ones. And in that river, they sensed a calm movement, slow, predictable, soothing, that carried them gently toward sleep. Night after night, the headline whisper returned to their thoughts, like a lantern flickering in a quiet hallway. They imagined the telescope capturing a faint glow, something subtle, like the softest ember in a dying fire. It wasn't loud enough to rewrite physics, not yet, but it was enough to stir the idea that there may have been a before the beginning. And that thought, instead of confusing them, lulled them deeper into quiet fascination. For some, the whisper conjured images of hidden universes layered like soft blankets, warm, ancient fabrics folded over one another, each carrying patterns from ages beyond imagining. They imagined the web peeking between these layers, catching the faint glimmer of something tucked between folds of cosmic cloth. And even though the science was complex, the feeling was simple: comfort, wonder, and a peaceful descent into restful curiosity. Others imagined a quiet cosmic room, vast beyond comprehension, where the universe kept its oldest memories. Maybe the Big Bang was just one doorway in that room, and maybe the telescope had accidentally glimpsed a shadow from a corridor behind it. The whisper didn't demand belief. It simply encouraged gentle imagining. And imagination, when softened by nighttime stillness, becomes a lullaby of its own. People reading the whisper late at night felt as though the universe had leaned close to them, not with urgency but with patient affection. It felt like being told a secret not meant to shock but to soothe, a secret that says the cosmos is deeper, wider, older, and more serene than we have ever known. And in that slow revelation, listeners felt their own worries shrink, dissolving like mist in the morning sun. As the whisper continued its soft path across the world, it became less of a headline and more of a presence, quiet, lingering, wrapped in stardust. It suggested that the universe might cradle memories older than itself, like a storyteller who remembers tales from lifetimes long forgotten. And as people rested with that thought, their breaths grew deeper, their minds quieter, their hearts calmer. Some imagined the Webb telescope leaning into that ancient darkness with the tenderness of someone listening for the last note of a fading song. And maybe, just maybe, it had heard a note that didn't belong to the symphony we know, a note from an older composition, one whose sheets have long been lost. The idea felt gentle, not frightening, as though the universe were humming softly to those willing to listen. Others pictured cosmic dust drifting slowly through vast silence, untouched for eons beyond counting. The whisper seemed to float like that dust, light, unhurried, graceful, settling gently onto the surface of the mind. And with each passing moment, the idea of something older than the Big Bang became less about defiance and more about wonder, like finding a tiny fossil embedded in the deepest stone, telling a quiet story. The whisper carried the sense that perhaps our understanding of beginnings is simply a doorway, not a wall. Maybe the universe has cycles, rhythms, breaths, each older than the last, each leaving faint traces that only something as patient as the Webb telescope could detect. And as that possibility brushed softly against the thoughts of listeners, their eyes grew heavier, welcoming the descent into restful dreams. People let their imaginations drift into the earliest darkness, a darkness not empty but gently glowing with potential. They pictured forms and patterns shimmering in that ancient space, too faint to name but too steady to ignore. The whisper suggested that we might be glimpsing those shadows, remnants of a time before time. And in that possibility, listeners found comfort, a reminder that beginnings are never as abrupt as they seem. Some found solace in the idea that the universe has been quietly shaping itself for far longer than we imagined. The whisper implied that the grand cosmic story may have chapters written before the first burst of light. And even though we cannot yet read those chapters clearly, the hint of them is enough to soothe the restless mind, guiding it gently toward stillness. The whisper settled into people's evenings like the final exhale before sleep, softening their thoughts and smoothing the edges of the day. It carried no urgency, no alarm, only the quiet suggestion that the cosmos is even more mysterious and serene than we have allowed ourselves to believe. And with that whisper resting beside them, they drifted slowly toward slumber, wrapped in the gentle hum of a universe older than its own dawn. And so, the headline whisper lingered, not to excite or unsettle, but to cradle minds in a story of vast, ancient calm, an invitation to imagine, to wonder, and to rest deeply within the quiet breath of the cosmos itself. What Webb actually does, a gentle lens into the past. It doesn't charge into the cosmos like a spotlight or announce its presence with any kind of cosmic noise. Instead, it simply opens its golden petals toward the dark, like a flower that blooms only under starlight. Through those hexagonal mirrors, it gathers ancient light traveling quietly across uncountable ages, allowing the universe to tell its story at its own slow, patient pace. And in that silence, the telescope becomes less a machine and more a soft doorway into eras that no longer exist yet somehow continue to whisper. People often imagine telescopes as eyes, but Webb feels more like a meditative listener, someone sitting in the dim glow of a fire, hearing every soft crackle and distant sigh. It listens to wavelengths too long and gentle for our eyes to notice, the warm infrared glow that objects keep even after billions of years have passed. Through that warmth, Webb learns the outlines of galaxies forming, stretching, twisting, becoming themselves long before any creature ever wondered about beginnings. It listens without interruption, without rush, letting history drift toward it like falling feathers. Its mirrors, polished to catch even the faintest shimmer, hold still in the cold of deep space, far from Earth's noisy warmth. That distance is like stepping away from a crowded room into a quiet garden. The view becomes clearer, calmer, more honest. And in that stillness, Webb captures the faint red-shifted glow of galaxies stretching away from us, their colors softened by time into hues like embers cooling in a gentle twilight. Each photon Webb receives has traveled so long that it feels like a tiny folded letter from the universe's childhood. What makes Webb unique isn't just its technical brilliance, it's the patience built into every part of it. It doesn't demand answers from the universe but waits for them gently. When light arrives, stretched thin by expansion, Webb doesn't hurry it along or try to force it into neat shapes. Instead, it unfolds each faint pattern slowly, revealing distant structures like the soft unfurling of petals. And listeners on Earth feel that calm patience echoing through the images, as though the universe is encouraging them to slow down too. Webb works with wavelengths that carry warmth, even from objects unimaginably old and distant. Infrared light slips through dust, weaving around cosmic clouds that once hid secrets from older telescopes. It slides through those curtains like a warm breath against cool air. Webb catches these whispers and translates them into gentle shapes, swirling nebulae, faint edges of baby galaxies, or the shadowy outlines of stars not yet born. In these softened colors, people feel a kind of cosmic lullaby, a reminder that creation itself can be quiet. Many telescopes look for brightness, but Webb looks for subtlety. It notices faint structures and dim glows that would be lost in brighter wavelengths. And because of that sensitivity, it can glimpse farther back in time than any eye or instrument before it. Each observation becomes a step deeper into the universe's early chapters, chapters written in soft strokes of ancient warmth, the kind that linger even after epochs have passed. And the more Webb listens, the more the universe's earliest memories drift into view. Floating far beyond the moon's orbit, Webb feels no tug from Earth's atmosphere, no trembling air, no flicker of distortion. Instead, its view is steady, serene, like gazing into perfectly still water that reflects stars untouched by wind. In that stillness, time stretches open. Light from billions of years ago arrives unchanged, carrying stories from when galaxies were only learning how to take shape. Webb simply opens its mirrors and lets those stories settle onto them, quiet as snowfall on untouched ground. From its vantage point, Webb doesn't just look outward, it looks backward. Every glimpse is a journey into history, as though the telescope has reached into a drawer of ancient photographs, each one faded but precious. It sees galaxies not as they are now, but as they were long before Earth formed, long before the Sun existed, long before the atoms in our bodies were forged. And this soft looking back feels like reading old letters written in a language of light, each message stretched by time into something beautifully fragile. The telescope's detectors can sense the faint heat of dust clouds that cradle forming stars, watching them glow softly like embers inside a cocoon. These scenes are so gentle, so slow, that they calm the mind simply by existing. And as Webb sends these images home, people feel themselves drifting into a slower rhythm, one shaped by billion-year processes where nothing hurried and nothing rushed. The universe becomes a place where even firestorms of creation unfold with careful grace. What Webb actually does is take the ancient universe, swaddled in darkness, and unwrap it layer by delicate layer. It sees past the bright fireworks of young stars into the veiled cradles behind them. It peers into the hearts of galaxies, uncovering dusty nurseries where light sleeps before fully awakening. Every discovery feels like turning a page in a storybook written across cosmic distances, with illustrations drawn in starlight that took entire lifetimes to reach us. In this gentle unveiling, Webb shows us not the universe rushing to expand, but the universe breathing, stretching, forming, reshaping itself in rhythms too slow for human senses. And Webb, with its patient mirrors, becomes the perfect companion for such slow truths. It doesn't distort them or rush to conclusions. It simply reflects what it sees, the way calm ponds reflect moonlight, softly, steadily, with a kind of quiet devotion. People often picture the telescope as a machine of discovery, but it feels more like a caretaker of forgotten light. It gathers lost photons that have wandered through the cosmic dark longer than human existence. When these photons settle onto Webb's sensors, it feels as though they have finally found a place to rest. And in their rest, they reveal things the universe has been keeping tucked away: tiny galaxies, elongated shadows, warm glimmers from epochs we cannot fully imagine. The instruments inside Webb are like finely tuned ears, each one attuned to a slightly different whisper. Together, they create a chorus of listening, patiently extracting meaning from the faintest signals. Nothing is rushed, nothing forced. The telescope processes each delicate wavelength with the care of someone dusting off an ancient artifact, making sure nothing breaks, nothing is overlooked. And through that care, the past becomes clear enough to touch with the imagination. Even its orbit contributes to its calm. Drifting around the L2 point, it experiences a balance between gravitational pulls, like a small boat floating on a perfectly still lake. This equilibrium allows it to keep its mirrors aligned without constant correction. As it drifts in this serene position, it continues gathering old light, each photon a traveler from a time long before Earth had oceans, mountains, or breath. Every time Webb captures a distant galaxy, it isn't just an image, it's a memory returned to the present. That galaxy may have changed completely by now, but Webb holds its past gently, preserving it the way one might preserve a pressed flower between pages. And because of that, the telescope becomes a kind of archivist, collecting snapshots of a universe that has long since moved on, yet still echoes with its earliest tones. Some of the earliest structures Webb sees are so faint they seem like smudges of soft dusk on a quiet horizon. But those smudges are ancient cities of stars, forming from gases barely warm enough to glow. By catching that glow, Webb reveals the shapes of things that once existed when the universe was still figuring out how to be itself. And in those shapes, there is something deeply soothing, proof that even the earliest moments unfolded slowly, gently. Webb's ability to sense cool temperatures gives it access to stories hidden from every previous telescope. It sees planets around distant stars, their atmospheres breathing faint signatures into the dark. It sees dust lanes winding like sleepy rivers through galaxies. It sees the remnant light of collisions that happened when the cosmos itself was barely an infant. Each of these glimpses, softened by distance, feels like a warm whisper reaching across time. Its sunshield, large and delicate, keeps it cool enough to notice these faint temperatures. Like a vast, serene umbrella stretched open under the glare of the sun, it shields the instruments from warmth, maintaining the quiet stillness needed to hear cold whispers from across the cosmos. That shield lets Webb focus entirely on the past, free from the noise of its own surroundings. And in that quiet, the universe's earliest breaths drift gently into view. Webb's mission is often described with scientific precision, but beneath all the equations, it remains a tool for quiet wonder. It reveals that the universe began not with chaos but with patterns, soft, drifting formations of matter that slowly gathered themselves into galaxies, then stars, then worlds. Its images remind people that creation is not only explosive but also tender, unfolding across epochs like slow-growing vines beneath starlight. Through all of this, Webb becomes a bridge, not one that rushes people across, but one that invites them to pause midway and look down into the depths of time. It offers a calm vantage point where past and present touch gently, where ancient light meets modern eyes without urgency. And in that meeting, something within each observer settles, quiets, softens. Ultimately, what Webb actually does is simple and profound. It listens to the universe's oldest memories with patience no human could ever match. And then, in quiet images sent across the void, it shares those memories with anyone willing to slow down long enough to see them. The telescope becomes a gentle storyteller, offering glimpses of ages beyond imagination, each one drifting softly into the mind like a dream on the edge of sleep. And as those dreams settle, people feel themselves drawn deeper into the quiet, as though the universe itself were tucking them in beneath a blanket of starlight and time. Distance is told by redshift, the universe's slow piano note. It is a quiet stretching of light, a gentle lengthening of each wave as it drifts farther and farther from its birthplace. Imagine a single piano key struck softly in a faraway room, the note fading as it travels down a long corridor. As it reaches you, the sound is deeper, slower, softened by distance. Redshift is the universe's version of that softened note, a signal that has traveled so long it has grown faint and warm, telling us how far, how old, how quiet the memory truly is. Light leaves its beginnings bright and sharp, but as it journeys through expanding space, it is pulled like fabric stretched gently in all directions. The farther it travels, the longer its wavelength becomes, sliding from energetic blues into warm reds, and beyond red into the invisible calm of infrared. Webb listens to those warm, elongated whispers, the ones so stretched by time that only something with infinite patience could capture them. In those whispers, distance and age become inseparable, woven into the same faint signal. The universe expands not with a bang or a shout but with a slow, steady outward breath. And every particle of light carries a record of that breath. As galaxies drift away from us, carried on the quiet tide of expansion, the light they send arrives not as it was, but as it has become shifted, softened, aged. Redshift is the language of that aging, a gentle translation of cosmic movement into color. And reading that color is like running a fingertip along the spine of time itself. People often imagine redshift as a measurement, a calculation, an equation scribbled on scientific diagrams. But beneath the numbers lies something much more tender, a record of how the universe has been stretching for billions of years, like a soft fabric slowly unfurling. Every shift in color is a note in that long cosmic melody. The higher the redshift, the older the song, the more distant the echo. Webb listens for those echoes with the attention of someone hearing a lullaby from childhood. When Webb peers into deep space, what it sees is not the present but a layered collection of fading notes. Each galaxy's light has been tuned downward by the long journey, its wavelengths resting gently in the infrared range, too soft for human eyes. It's as though the universe has wrapped these distant structures in warm twilight, and Webb, with its sensitive detectors, peels back the twilight layer by layer. In doing so, it reveals entire clusters of galaxies that glowed when the cosmos was still young. The idea that distance is measured in color feels poetic, almost unreal, yet it is how the universe naturally speaks. The farther something is, the redder its light becomes, like a lantern glimpsed through mist. Webb doesn't chase the lantern, it simply waits for the soft glow to arrive, catching it as tenderly as one might cup fireflies in open hands. That glow carries not only distance but memory, whispering of stars long gone and galaxies still in their earliest breaths. As light stretches, it cools. What was once bright and energetic becomes gentle and warm, and in that warmth lies information about ages long past. Webb's instruments were crafted precisely for this warmth, able to sense tiny variations in the faint red-shifted glow. Each variation becomes a clue how much space has expanded, how quickly the galaxy was moving, how long the light has been drifting. In those clues, the telescope assembles a picture of cosmic history, one soft pixel at a time. When astronomers speak of redshift, they speak of Z values, scales, and models. But to someone drifting toward sleep, redshift is more like watching a distant candle slowly dim as you walk away from it. The flame doesn't weaken, it simply becomes gentler in your eyes because of the space between you. The same happens with galaxies, they shine fiercely, but the vastness between us smooths their light into something softer, something the universe delivers like a fading lullaby to Webb's golden mirrors. The most distant galaxies Webb sees are not red in the way we imagine, but stretched far beyond red, deep into a warmth invisible to us. They glow like embers buried under layers of cooling ash, still shimmering faintly after an unimaginable stretch of time. Webb's detectors, sensitive to this faint warmth, gently uncover the embers, brushing away the darkness like someone clearing dust from an ancient stone. And what emerges is a glimpse of the universe long before it took the shape we recognize. Redshift tells us how much the universe has grown since the light began its journey. A high redshift means the cosmos was young, small, tightly curled around itself like a child asleep. When Webb looks at a galaxy with extreme redshift, it is peering into that childhood, seeing a time when structures were fragile, newly forming, still learning to gather stars into swirling patterns. Webb becomes a timekeeper, translating the stretching of light into a story of cosmic growth. If light could speak in words, its message would be simple: I have traveled far, and I carry the shape of my journey. But because it speaks in wavelength, instruments like Webb must become translators. They convert the stretched glow into distance, age, velocity. Each converted signal becomes a soft footprint on the path back to the beginning. And following these footprints feels like wandering down a quiet, dimly lit trail where the leaves rustle gently with memories older than the earth. The stretching of light is so subtle that it would go unnoticed without the sensitivity of Webb's instruments. Yet once detected, it becomes a profound storyteller. A galaxy with slight redshift is nearby in cosmic terms, its light only lightly aged. But a galaxy with heavy redshift has light that has traveled for billions of years, passing through epochs of cosmic shaping. In the deep quiet of space, that journey whispers through every stretched wavelength, and Webb leans in to hear. Redshift is not only a measurement of distance, it is evidence of the universe's expansion, a slow, steady unfolding that has continued since the earliest moments of existence. When Webb detects high redshift objects, it isn't merely identifying faraway points, It is witnessing the universe at its most tender stages. These distant galaxies appear small, faint, almost fragile, like early sketches of what galaxies would one day become. Webb treats them with the gentle reverence one might give to a fragile relic. The deeper Webb looks, the more redshift becomes a guidepost. Each faint glow it sees has been stretched by billions of years of cosmic movement, and the greater the stretch, the farther back in time Webb is peering. It is a journey through layers of history, each layer telling the story of a universe slowly organizing itself. And as these layers accumulate into images, people sense the softness of a universe that took its time to build itself into the grand celestial tapestry we know. Redshift also tells us that the universe is not static, it is still expanding, still breathing outward. The galaxies in Webb's deepest fields are rushing away from us at incredible speeds, yet their faint redshifted light reaches us calmly, like a message placed into a bottle and set adrift on a vast ocean. When Webb retrieves these cosmic messages, it reads them with care, learning about distant epochs as if listening to the gentle voice of an ancient traveler. In this soft stretching of light, scientists find the rhythm of cosmic time, a rhythm slow enough to cradle the mind. High redshift galaxies become markers on the universe's long timeline, points of reference that tell us how quickly matter gathered and how early stars flickered into existence. Webb's ability to resolve these remote structures reveals how the earliest galaxies formed in quiet clusters, glowing dimly as they arranged themselves into the universe's first shimmering shapes. To imagine redshift intuitively, one might picture a long silk ribbon being pulled slowly across a room. The more it stretches, the more its patterns elongate, becoming softer and less distinct. Light behaves the same way across cosmic distances. And Webb, with its sensitivity to stretched wavelengths, detects the patterns on that cosmic ribbon even when they are faint, faded, nearly erased by time. It identifies their origins and places them carefully onto the map of cosmic history. When Webb discovered the most distant galaxies ever observed, the shock was not loud or dramatic, it was quiet, almost like hearing a forgotten note in an old song. These galaxies were too bright, too formed, too early. Their redshift suggested they existed when the universe was barely beginning its expansion. And the idea of such early structures felt like an unexpected chord in the cosmic melody, one that made the listeners pause and breathe deeply, absorbing the new harmony. Redshift turns the night sky into a timeline, with nearby galaxies speaking in soft blues and faraway galaxies singing in deep reds and infrared warmth. Webb listens to this layered choir, isolating the faintest voices, the ones drifting from the universe's earliest minutes. It doesn't silence the louder nearby notes, it simply focuses on the gentlest ones, the ancient tones that carry the echoes of formation, clustering, and the slow rise of cosmic structure. Some galaxies Webb finds are shifted so far into the infrared that they represent the universe just a few 100 million years after its birth. Their redshift is extreme, like a piano note stretched into a long, slow hum. Discovering them feels like opening a door into a dim room where the earliest stars flicker like candles, still learning how to shine. These discoveries soothe the imagination because they show that even the earliest cosmic moments unfolded with slow grace. Redshift also reveals the speed at which galaxies drift away from us, carried by expansion. Faster movement means greater stretching, greater distance, greater age. And in that acceleration lies the evidence for dark energy, a mysterious force causing the universe to expand faster over time. Webb doesn't measure dark energy directly, but the redshift patterns it collects become quiet clues, gentle curves in the data that hint at the universe's ongoing breath. Through all this, Webb's work with redshift becomes more than analysis, it becomes a calm reading of cosmic memory. Each wavelength tells how far it traveled, how long it wandered, how much the universe expanded along the way. Webb interprets these stories with patience, turning the stretched light into a peaceful chronicle of ages long past. And listeners on Earth, hearing the results, find themselves drifting into a soft contemplation of distance and time. In the end, distance through redshift becomes the universe's slow piano note, an ancient tone stretched across billions of years, arriving in our present as a gentle hum. Webb hears that hum with exquisite sensitivity, turning it into images, measurements, and memories. And as people gaze upon the results, they feel wrapped in the serene understanding that the universe plays its music slowly, carefully, and beautifully across the vastness of time. Photometric guesses versus spectroscopic answers, a quiet, two-step test. In the calm world of distant galaxies, nothing is ever known all at once. Instead, astronomers begin with gentle impressions, soft hints carried by the faint glow of faraway objects. Photometry gathers these hints by measuring brightness through different filters, like holding thinly colored glass up to candlelight. The results give a suggestion, a whisper of how distant or ancient something might be, but the whisper is uncertain, like trying to guess a melody after hearing only one softened note drifting from another room. Photometry is fast, sensitive, and beautifully broad, which makes it perfect for the first glance into cosmic darkness. It notices subtle drops or rises in brightness, patterns that resemble the imprints left by the stretching of light across space. These patterns help scientists estimate redshift, offering early guesses about how far the light has traveled. But because these guesses depend on how brightness is interpreted, they can be fooled by dust, by overlapping galaxies, or by surprising colors born from cosmic processes still not fully understood. Photometry is the universe's sketchbook, accurate enough to inspire, uncertain enough to require patience. These photometric hints often lead Webb to suspect that it has glimpsed something extraordinary, perhaps a galaxy from the universe's earliest dawn, glowing softly at a redshift that seems impossibly high. But suspicion is not certainty. Photometric redshifts whisper, maybe, with a voice that is gentle but incomplete. And in science, maybe is an invitation to look more closely, breathe more slowly, and seek a clearer signal. That clearer signal comes from spectroscopy, the second step, the careful verification that turns whispers into measured truth. Spectroscopy is not fast or broad. It is focused, patient, attentive, like a quiet listener leaning close to hear every subtle syllable in a soft voice. Instead of measuring brightness through filters, spectroscopy breaks light into its full, delicate spectrum, separating it into fine threads the way a prism spreads sunlight into a rainbow. In these threads, dark fingerprints appear, absorption lines where specific atoms absorbed specific wavelengths billions of years ago. Those fingerprints shift with redshift, giving a precise measurement of distance that cannot be mistaken. When photometry suggests a high redshift galaxy, spectroscopy steps forward like someone gently confirming the identity of a lost traveler. It looks for the telltale signatures of hydrogen, oxygen, and other ancient elements, stretched into new wavelengths by cosmic expansion. If these features appear exactly where the predictions fall, the distance becomes clear, no guesswork, no uncertainty, no fragile assumptions. The galaxy's place in cosmic history becomes anchored, its story told with quiet certainty. And in this confirmation, astronomers breathe easier, knowing the early whispers were truly ancient. But spectroscopy requires time, long exposures, delicate adjustments, and the faintest light gathered patiently. For the most distant galaxies, the photons are so sparse that they arrive one by one, like tiny taps of rain on a quiet window. Webb listens to these taps across hours, sometimes days, building enough signal to reveal the spectral lines hidden within. It is a process of immense calm, where the universe reveals itself only as quickly as its light allows. No rush, no force, only waiting. This two-step test, first photometry's broad guess, then spectroscopy's sharp answer, creates a rhythm to Webb's discoveries. At first there is excitement, a faint glow in a deep field image, unusually bright for its color, hinting at immense distance. Then there is caution. The the recognition that colors can deceive, that dust can mimic redshift, that chance alignments can create illusions. Finally, there is the deliberate act of checking the spectrum, the way one might reread a delicate letter from long ago to ensure no meaning is misunderstood. The universe often hides its earliest chapters behind layers of complexity. A galaxy may appear red not because of ancient distance, but because of thick dust glowing in infrared warmth. Photometry alone cannot always distinguish such disguises. Only spectroscopy reveals the truth, showing whether the wavelengths have been stretched by billions of years of expansion or simply colored by clouds of cosmic dust. In this way, spectroscopy becomes a teacher, reminding astronomers that appearances can mislead, but patient analysis brings clarity. Some of the earliest claims of extremely distant galaxies turned out to be mistaken, their photometric guesses too optimistic. Yet this is not a failure, it is part of the gentle process of learning. Photometry casts a wide net, gathering possibilities, while spectroscopy sorts those possibilities with care. The relationship between the two methods is like the relationship between imagination and verification, both essential, both complementary, both necessary to build an honest map of the cosmos. When Webb found galaxies that seemed impossibly early, some with photometric redshifts beyond what theories predicted, the excitement was immense. But even then, scientists whispered to themselves, "Wait for the spectra." These whispers carried wisdom, because the universe has surprised astronomers before. And in those surprises, the quiet discipline of checking the details, of letting the spectrum speak, proved invaluable. Webb's early results echoed this teaching. Balancing wonder with restraint. Spectroscopy is like turning on a small lamp in a dark room. Suddenly, the shadows sharpen, the contours appear, and the guessing ends. The faint smudges in photometric images become definite galaxies with measurable chemical fingerprints. Their formation times, their histories, their movements all become clearer. And with this clarity comes a deeper appreciation. The universe is not only beautiful in its mysteries, but also in its patient unfolding of answers. Photometry's gift is speed and breadth. Spectroscopy's gift is certainty and detail. Together, they weave a soft partnership, each step holding its own kind of serenity. Photometry lights the path, spectroscopy draws the map. Photometry opens the door, spectroscopy reads the inscription carved into the threshold. And Webb moves between the two methods like someone walking slowly through a gallery, first admiring the colors from afar, then leaning in to examine the delicate strokes. Even the instruments inside Webb reflect this harmony. Its cameras gather broad photometric data across many filters, catching faint candidates with wide sensitivity. Its spectrographs, on the other hand, focus like narrow funnels, capturing the precise structure of light through slit masks and microshutters. These tools operate not in conflict but in balanced cooperation, each embracing a different role in the quiet pursuit of ancient truths. Sometimes, photometric guesses turn out to be true gems, distant galaxies glowing from the universe's early childhood. Other times, the spectroscopic check reveals a trick of dust or a blend of overlapping objects. But even when guesses are proven wrong, the process remains gentle, without disappointment. Every result teaches something, about dust, about light, about galaxy behavior, about the delicate ways the universe paints itself across time. Each correction is a deepening of understanding rather than a loss. The two-step test forms the heartbeat of early universe research. It mirrors the way we learn anything new, first impressions followed by careful listening, assumptions softened by slow verification. Webb's work becomes a metaphor for patience, the idea that even in the grandest mysteries, truth arrives quietly, one wavelength at a time. Photometry invites curiosity, spectroscopy answers with calm certainty, and together they create a dialogue that stretches across cosmic history. There is something soothing in the idea that the universe does not reveal its secrets instantly. The soft glow of a distant galaxy must be inspected gently, interpreted with care, confirmed with precision. This measured approach is comforting, like slowly unfolding a delicate cloth that has been stored for ages. Webb's method reminds us that understanding is not rushed, it is something we grow into, layer by layer, just as the universe grew into itself across billions of years. Photometric redshifts often come with a range of possibilities. A galaxy might be ancient, or it might simply mimic the colors of ancient light. The probabilities narrow as more filters are added, but uncertainties remain. Spectroscopy removes those uncertainties by revealing exact shifts in known absorption features. These features act like quiet anchors, fixing the galaxy's age and distance firmly onto the cosmic timeline. It is in these anchored results that people find peace, knowing the measurement is not a guess but a truth. In some cases, spectroscopy is nearly impossible. The galaxies are too faint, the signals too thin. In those situations, photometry remains the only guide, and scientists accept its limitations with humility. But when spectroscopy is possible, it transforms a blurred possibility into a sharply defined memory. It is the difference between hearing a muffled voice through a wall and hearing it clearly when the door opens. And Webb, with its sensitivity, opens many such doors. The slow gathering of photons for spectroscopy is almost meditative. The telescope waits silently, letting ancient light accumulate until its patterns become visible. That waiting mirrors the vastness of cosmic time, the billions of years the photons spent traveling, the epochs they crossed, the changes the universe underwent while they journeyed. The act of receiving them patiently feels like honoring that long journey, acknowledging the effort light makes to tell its story. Photometry often leads the way in discovering surprising objects, galaxies brighter or more numerous than expected at early times. These discoveries spark questions about how quickly the universe formed structures. But spectroscopy determines which surprises are real and which are illusions. It sharpens theories, corrects models, and grounds imagination with evidence. And yet, it never diminishes the wonder. Instead, it deepens it, because the confirmed truths are even more powerful than the early guesses. As Webb continues to observe, the dance between photometric hints and spectroscopic answers shapes our understanding of the early cosmos. This dance is slow and careful, a sequence where each step depends on the last. And like a quiet duet, it unfolds with grace, one method suggesting possibilities, the other confirming them, both working in harmony to reveal the universe not in bursts, but in gentle unveilings. In the end, photometry and spectroscopy form a peaceful dialogue between curiosity and clarity. Photometry asks, could this be something ancient? Spectroscopy replies, yes, this is its true story. And in that exchange, the universe's earliest light becomes more than a distant glow, it becomes a narrative, a memory shared across time. Webb listens to both voices, weaving them into a calm, continuous understanding of how everything began. When astronomers speak of a galaxy's age, they aren't tracing wrinkles or counting cosmic rings. Instead, they listen to the soft hum of its starlight, noticing how the glow changes with time. Stars born in hot, brilliant bursts tend to sing in bright blues, while older stars whisper in warmer ambers and reds, leaving behind a melody that stretches across wavelengths. By studying this quiet chorus, scientists begin to understand how long those stars have been shining, building a story that unfolds gently through light alone. This lullaby of light is captured by instruments like those on the James Webb Space Telescope, which gathers faint photons that left their galaxies billions of years ago. Astronomers then compare the brightness, colors, and shape of the spectral curve to models that predict what a galaxy should look like at different stages of its life. In this comparison, the ancient glow reveals secrets otherwise unreachable, like reading the fading ink on a page written before Earth ever existed, unfolding slowly and patiently through the data. Of course, The light from galaxies is complicated, drifting through cosmic distances where dust clouds, gas streams, and star-forming regions mix their voices together. To separate them, scientists rely on detailed algorithms that peel back layers of the spectrum, isolating each gentle tone. The result feels like restoring an ancient lullaby recorded on a fragile disc, carefully reducing noise until the true melody emerges, one that carries hints about age, composition, and the rate at which new stars awaken. The younger a galaxy is, the more its blue-hot stars dominate its song, filling the spectrum with high-energy notes that shimmer with intensity. Over time, as these massive stars burn out and gentler, longer-lived ones remain, the melody shifts toward calmer, warmer wavelengths. This change is gradual, like morning fading into evening, and when astronomers measure it, they're tracing the passage of billions of years with the precision of someone listening for small changes in a long, slow piece of music. But starlight alone isn't enough. Astronomers also study elements forged inside stars and spread through a galaxy as they live and die. The ratio of elements like oxygen, iron, and carbon becomes a record of how many stellar generations have passed. Each element adds a new layer to the lullaby, telling researchers whether the galaxy has had time to enrich itself or remains chemically young. This chemical fingerprint intertwines with light patterns, strengthening the estimate of its true age. Dust inside galaxies complicates the melody further, absorbing blue light and making the galaxy appear older than it really is. Astronomers must correct for this, adjusting the spectrum to account for the veil of cosmic soot that dims and reddens everything behind it. These corrections require careful modeling, because even a slight misinterpretation can shift age estimates by hundreds of millions of years. But with Webb's infrared sensitivity, much of that dust becomes transparent, helping the true song emerge. Another technique involves analyzing the rate at which stars form in the galaxy, its star formation history. If the galaxy is currently bursting with new stars, its age estimate must account for this youthful activity rather than misclassifying it as an older system glowing softly. The ebb and flow of star formation across time leaves distinctive marks in the spectrum, like crescendos and pauses in a long lullaby, and by mapping these changes, astronomers reconstruct the galaxy's own timeline. Sometimes, astronomers detect older stars hidden inside a galaxy that otherwise appears youthful. These older stars, faint but steady, act like memory keepers, reminding researchers that the galaxy's past stretches farther back than its newer, brighter stars suggest. In this way, age estimation becomes an act of patience, listening not just to the loudest voices, but also to the quiet, persistent ones that have been singing the longest. The redshift of a galaxy adds another constraint, revealing how far its light has traveled and thus setting an upper limit on its possible age. A galaxy, observed at a redshift corresponding to 500 million years after the Big Bang, for example, cannot truly be older than that moment, no matter how mature its internal light seems. This acts as a cosmic boundary, ensuring age estimates stay grounded in the fabric of spacetime itself, preventing illusions that arise from unusual light patterns. To refine these estimates, astronomers fit the galaxy's spectral energy distribution, its full light curve from ultraviolet to infrared, to theoretical models. These models simulate how stars evolve over billions of years and how their combined glow changes. When the observed curve matches a theoretical one closely, astronomers infer a likely age. Yet this is not a single number answer. Instead, it's a range of possibilities softened by uncertainties, much like interpreting a whispered line of music. Even with advanced tools, age estimates can shift when new data arrives, especially from instruments as sensitive as Webb. A galaxy previously thought to be ancient based on limited data may reveal younger features in clearer spectra, forcing scientists to re-evaluate earlier conclusions. This humility is part of the cosmic listening process, acknowledging that the universe sometimes plays tricks with faint light stretched thin by distance and time. Some galaxies appear surprisingly mature for their cosmic era, possessing heavy element enrichment and older star populations earlier than expected. These discoveries challenge existing models, prompting researchers to wonder whether star formation began sooner, happened more efficiently, or unfolded differently than predicted. Every such puzzle invites deeper listening, as if the lullaby suddenly shifts key and asks for closer attention to its structure. Astronomers also consider the mass of a galaxy when estimating age. More massive galaxies can form stars rapidly, creating a population that ages together. A massive galaxy with very little ongoing star formation often indicates an early, intense burst of stellar creation that ended long ago. Its light then resembles a quiet choir of elder stars, offering yet another clue to its long, slow evolution through cosmic time. But age is not uniform across a galaxy. Different regions can carry different histories. The core might host older stars while the outskirts glow with youthful clusters just beginning their lives. Observations must therefore average these differences, acknowledging that a galaxy is a collection of many overlapping lullabies, each telling a slightly different story. The final estimate becomes a blend, much like combining many soft voices into a single harmonious tone. In some cases, gravitational lensing helps reveal galaxies too faint to observe otherwise. When light is magnified by massive foreground objects, faint details become visible, allowing astronomers to reconstruct the age of tiny, early universe galaxies that would otherwise remain unheard. These magnified lullabies can be faint, distorted, or incomplete, but even fragments offer precious insight into early star formation. Age estimation also relies on comparing galaxies at different epochs, creating a timeline of how galactic properties evolve. By observing many galaxies across a range of redshifts, astronomers create a cosmic choir, where each galaxy represents a note in time. Patterns emerge across the ensemble, helping them identify what a galaxy of a certain age should generally look like, strengthening individual age estimates. The concept of stellar population synthesis lies at the heart of this work. Scientists combine different simulated groups of stars, young, old, metal-poor, metal-rich, to match the observed light of a galaxy. This synthesis is like composing a piece of music until it echoes the real one closely. When the match feels right, the age can be estimated from the proportions of these simulated components, revealing how much of the galaxy's history is dominated by older or younger stars. Even after careful modeling, uncertainty remains. Age estimation is probabilistic, based on fits that carry assumptions about how stars behave and how galaxies evolve. Yet these uncertainties do not undermine the process. Instead, they remind astronomers that they are interpreting ancient whispers carried across unimaginable distances. The beauty lies not in perfect certainty, but in the gentle act of listening to the universe's faintest songs. The earliest galaxies often challenge expectations, glowing with surprising brightness or complexity. Their age estimates must therefore be checked against multiple models, ensuring no single assumption skews the interpretation. This cautious approach keeps the science grounded, allowing astronomers to refine theories of early cosmic structure formation as new data arrives. Webb's infrared sensitivity opens access to older, cooler stars that were hidden from previous telescopes, improving age estimates significantly. By capturing the soft, red tail of starlight, Webb enables scientists to detect ancient stellar populations that anchor the age calculations more reliably. These older stars form the backbone of a galaxy's lullaby, steady and deep in tone, revealing a history that once lay beyond reach. At high redshifts, however, the light is stretched so much that certain features shift into wavelengths difficult to observe. This complicates age estimation because key spectral features may be faint or entirely shifted out of view. Scientists must then rely on creative modeling and comparisons with nearby analogues, crafting age estimates from whatever faint fragments remain, treating each clue with gentle interpretation. As age estimates improve, They inform models of how the first stars and galaxies formed. The timing of early star formation affects how quickly heavier elements spread, how early black holes grew, and how the first cosmic structures assembled. Each galaxy's age becomes a stitch in the fabric of cosmic history, weaving a clearer picture of how the universe matured from a hot plasma into the richly structured cosmos we see. Yet even with all these techniques, astronomers remain open to surprises. Sometimes the lullaby carries unexpected harmonies, spectral shapes that do not match any model cleanly. These anomalies push scientists to revise assumptions about early star formation or the physics of light travel, allowing the universe to continue teaching them. In this way, estimating a galaxy's age becomes a dialogue, a slow and soothing exchange between human curiosity and cosmic memory. Ultimately, the process of reading a galaxy's age is a meditation on patience. Light that has traveled billions of years arrives in a whisper, faint but full of meaning. Astronomers gather these whispers, compare them, question them, and slowly shape them into understanding. Each estimate is not just a number but a quiet acknowledgement that in the vastness of space, even the oldest things continue to sing softly across time. When people hear that Webb found something older than the Big Bang, the phrase may flutter through their thoughts like a startling breeze in a quiet room, but the universe has a simple and unbreakable anchor. Nothing we observe can truly be older than the event that created spacetime itself. The Big Bang isn't just the birth of matter, it's the beginning of time, the moment the cosmic clock first ticked. So when a galaxy seems older, the issue is not reality breaking, but our interpretation bending, reminding us that measurements, like faint lullabies drifting from billions of years away, can mislead even the most careful listener. The light from distant galaxies travels through a universe that stretches that light as it goes, shifting colors and weakening signals until the original message becomes blurred. When astronomers estimate ages from these faint signals, they must untangle many layers of distortion, dust that reddens the light, stars of different temperatures blending their glow, and redshift stretching every wavelength. If any of these layers are misinterpreted, the galaxy's age can appear older than it truly is, creating the illusion that it outlived the universe itself when in truth it simply sings a confusing melody. Much of the confusion arises from modeling starlight. Scientists compare the galaxy's glow with predictions generated by computers, and if the glow resembles the signature of an older stellar population, the model may lean toward that conclusion. But a galaxy filled with dust or bursting with bright stars that mimic older tones can deceive the models. In such moments, the galaxy does not defy the birth of time, it only tricks our tools, like a voice echoing in a canyon sounding older, deeper, or richer than the speaker who uttered it. Another factor is that galaxies forming extremely early in cosmic history can look surprisingly mature because the universe was more efficient at building stars in its youth. Conditions were dense, energetic, and ripe for rapid formation, allowing some galaxies to assemble large, bright populations of stars much faster than expected. These rapid builders might appear older in starlight analysis not because they existed before time, but because they grew up very quickly, like a child who suddenly speaks with the gravity of an elder. Redshift estimates also play a role in these misunderstandings. When the distance to a galaxy is inferred using photometry alone, broad colors rather than detailed spectra, it can be skewed. A galaxy that is actually closer, and therefore younger in appearance, might be mistaken for one from the dawn of the universe. Once the estimated distance is wrong, every other metric, including age, becomes tangled. The result is an illusion of impossible antiquity, corrected only when high-resolution spectra clarify the truth. The Big Bang acts as a boundary for all such interpretations. It is not a theory in the fragile sense of the word, it is a framework. Supported by cosmic microwave background measurements, large-scale structure mapping, nuclear formation predictions, and countless observations across decades. So when something appears older, Scientists do not panic or rewrite physics, they calmly reinforce the anchor. The universe has an age, and nothing can predate the fabric of time that holds everything within it. Instead, astronomers lean in closer, listening for subtler harmonies. Perhaps the galaxy's light passed through unexpected dust, perhaps its star formation history was misread, or perhaps something about the model assumptions failed at extreme distances. These possibilities whisper with far more realism than the idea of a galaxy floating before time began. The cosmos is full of surprises, but it has never asked us to believe that anything slipped through existence before existence itself. Instruments also have limits. Even Webb, capable of capturing photons older than any story humanity has ever told, works with data stretched thin across unfathomable distances. Faint galaxies near the detection threshold can yield incomplete spectral information, making age estimates more fragile. A missing emission line here or a weaker absorption feature there can nudge models in misleading directions, turning a young but dusty system into one that looks like an ancient relic. These mistakes are not errors in physics but the natural imperfections of measurement. Another source of confusion is the behavior of stars in the earliest eras. The first generations of stars may have been different, larger, hotter, shorter-lived, and their remnants might produce light curves that modern models don't fully capture. If models assume later universe behavior for these early universe populations, the mismatch can inflate apparent ages. It's like trying to judge the age of a tree species you've never seen before using the growth rings of a familiar one. The logic may hold broadly, but the details can skew everything. Furthermore, galaxies sometimes experience bursts of activity followed by long quiet periods. A galaxy might form a large group of stars early, then go dormant, leaving its starlight dominated by older stars even though it is not itself ancient in any literal cosmic sense. If astronomers catch only the fading glow of that early burst without seeing the later, quieter evolution, the models might assume an age beyond what is possible. Here again, the lullaby is not lying, it is incomplete. There is also the simple matter of statistical uncertainty. Age estimation curves typically stretch across a range of possibilities, and when a headline claims a galaxy is 13.6 billion years old, what might really be meant is that the center of the curve lies near that number, while the broader spread dips down to far more reasonable values. Headlines rarely mention statistical error bars, even though those bars are where the truth gently rests, ensuring nothing truly challenges the universe's beginning. The reason scientists remain calm is because all the evidence we have, the cooling of the cosmic microwave background, the formation of light elements in the first few minutes, the distribution of galaxies, converges on a consistent timeline. Nothing in the distant universe has ever forced the conclusion that the Big Bang is incorrect. Instead, anomalies nudge models forward, refine understanding, and invite humbler interpretations. An older-than-time galaxy becomes an opportunity, not a contradiction. Many galaxies initially thought to be impossibly old were later reclassified when better data arrived. Spectroscopic follow-up often revealed lower redshifts, younger stellar populations, or unexpected emission lines that dramatically corrected age estimates. These recalibrations happen quietly and frequently, reinforcing that these cosmic puzzles arise from limited measurements, not rewritten laws. The Big Bang remains untouched, steady beneath the ebb and flow of new data. Even when a galaxy appears unusually mature for its epoch, well-organized, chemically enriched, or massive, scientists interpret this as nature working faster or differently under early conditions, not as something that slipped into existence before the universe allowed it. The universe's early years were dense and creative, packed with enough material to spark rapid star formation. Maturity does not equal impossible age, it simply means the cosmos was efficient when young. High redshift galaxies are also affected by cosmic variance, the randomness of where we happen to look. A region dense with early structure might appear unusually evolved compared to an average patch of space. This doesn't imply that galaxies existed before the universe itself, only that different pockets of space matured at different rates. Variation is not contradiction, it is part of the universe's natural texture. When interpreting these distant signals, astronomers build multiple models, cross-check them, and look for consistency. Across wavelengths. If different models produce wildly different age estimates, this signals uncertainty, not a violation of cosmic rules. With JWST delivering unprecedented clarity, many previous assumptions need updating, but this refining of knowledge is expected, not alarming. Science grows through revision, not crisis. Some galaxies may contain older star clusters whose formation began very early, giving the impression of an ancient system. These clusters themselves are not older than the universe, they are simply among the first to ignite. A galaxy hosting them may appear mature, but maturity does not push the boundaries of cosmic time. It simply means we are witnessing one of the earliest chapters written by gravity. When astronomers speak of something challenging cosmology, they never mean breaking time. They mean the models of early star formation, or the assumed pace at which structure forms, or the behavior of gas during the cosmic dawn might require adjustment. The foundation, that time began at the Big Bang, remains unshaken because countless independent measurements corroborate it. Even the idea of age becomes trickier the farther back we look. Time itself is measured relative to the universe's expansion, and the early universe experienced rapid changes in density, temperature, and structure formation. A galaxy appearing older than expected might simply reflect processes that occurred faster during that intense epoch. The laws remain intact, it's our expectations that soften and adapt. In many reports, what appears to be an age is actually the model's preferred fit for a limited dataset, not a definitive measurement. A better dataset would likely shift the answer. Scientists know this, which is why they handle such claims with calm skepticism. They understand that distant galaxies whisper through layers of noise, and that any interpretation requires caution. The phrase older than the Big Bang therefore reflects a misunderstanding of how age is inferred, not a discovery of impossible chronology. It shows how poetic language, appealing in headlines, can distort the nuance of early universe astrophysics. The truth is gentler. The universe offers puzzles, not paradoxes, and these puzzles guide the refinement of our cosmic story. Because of this, astronomers always work within the framework that the universe has a maximum age of about 13.8 billion years. Any galaxy appearing older must be reconsidered, remeasured, and reinterpreted. This is not stubbornness, it is alignment with overwhelming observational evidence. The universe has boundaries, and age is one of them, as steady and calm as a lighthouse beam across a dark sea. The Big Bang marks the beginning of causality, the moment when energy, space, and time became linked. Nothing can precede it because before is a concept that loses meaning without time to define it. Thus, when a galaxy's light seems to whisper otherwise, astronomers treat it not as a cosmic rebellion but as a clue that something in the analysis must be tuned more precisely. Every time JWST uncovers a galaxy that looks too old, it becomes a reminder of how much more there is to learn about the earliest stars. Perhaps the first stars formed sooner than previously thought, or in larger clusters, or with characteristics not yet fully incorporated into models. The universe nudges us gently. The rules hold, but our understanding of their early application still deepens. Misinterpretations often dissolve once dust corrections, star formation histories, and redshift uncertainties are accounted for. Suddenly, an impossible galaxy becomes merely surprising, a much more comfortable category that fits within cosmic logic. The universe does not resist its boundaries, it merely invites us to look closer, refine assumptions, and let our curiosity mature along with our models. In this way, nothing about the cosmos ever claims to be older than the Big Bang. Instead, the cosmos teaches us that even the faintest, Most distant lullabies can confuse the listener if the melody is faint or the instruments are imperfect. The rule remains calm and firm: time began once, and the universe has honored that beginning ever since. There is a kind of quiet fog that often curls around cosmic discoveries, drifting into the minds of readers who hear grand claims before they hear the grounding explanations behind them. When people read that the James Webb Space Telescope saw galaxies so ancient, so compact, so unexpectedly bright, the imagination sometimes leaps a little farther than the data intended. That leap, innocent as moonlight slipping across a sleeping face, becomes the seed of confusion. It grows when excitement outpaces understanding, when headlines choose drama over clarity, and when the enormity of the universe invites metaphors that sound factual even when they're only poetic shortcuts. And in that soft, hazy space, misunderstandings begin to bloom like mist-lit flowers. One of the gentlest culprits is the language of earliest, oldest, and first, because these words feel solid in everyday life but become slippery when applied to the cosmic scale. When scientists say a galaxy is among the earliest ever observed, they do not mean it predates the universe, they simply mean it formed earlier than we once expected. Yet the small shift in phrasing between earlier than predicted and older than the universe is easy to miss here, especially when the universe's timeline feels so abstract, stretched across billions of years. And so people may accidentally interpret early as impossible, old as paradoxical, and surprising as contradictory, even though the truth is simply that the story of galaxy formation contains more chapters than we assumed. Another source of confusion comes from the way telescopes look across time rather than across distance alone. When Webb sees a galaxy 13.5 billion years in the past, it's not peering at something older than the Big Bang, it's observing light that has traveled to us since shortly after the universe cooled enough for stars to ignite. Yet because we do not live with time-stretched vision, the idea that distance equals age can feel counterintuitive. We are used to distance being measured in meters, kilometers, hours of travel, not epochs. So the brain tries to anchor the concept to something familiar, and in doing so, sometimes accidentally flips the meaning around, imagining light older than the event that created light itself. The misunderstanding is gentle, born not of ignorance but of human instinct. Another culprit drifts in from the realm of metaphor, the poetic descriptions scientists used to help the public feel the scale of their discoveries. Phrases like peering into cosmic dawn, seeing the universe's earliest light, or uncovering ancient cosmic fossils help bring wonder alive, but they can also blur the line between imagery and literal interpretation. Cosmic dawn was not a single moment but a long period. Earliest light was not instant illumination but a slow emergence from primordial darkness. And fossils in space don't behave like fossils in rock. These metaphors are meant to comfort and invite, yet when repeated without context, they can encourage the listener to mistake illustration for fact, the way a dream can momentarily feel like waking life. The complexity of redshift adds another layer to the confusion, like a soft veil the mind struggles to lift. Redshift is the stretching of light due to the expansion of space, and Webb identifies distant galaxies largely by measuring how stretched that light has become. But when the numbers appear, redshift 10, redshift 13, redshift 15, they can create an illusion of precision without understanding. People might assume these values directly translate to age in simple, linear steps. They do not. They require models, assumptions, calibrations, and careful interpretation. The difference between one redshift estimate and another can shift a galaxy's inferred age by hundreds of millions of years, yet to a casual reader, the numbers might look fixed, final, or absolute. That rigidity can give rise to the mistaken belief that a measurement contradicting expectations must contradict the universe itself. Another gentle culprit arises from misunderstandings about what telescopes actually see. When Webb captures an image, it is not a raw photograph in the everyday sense but a carefully processed composite of infrared wavelengths, filtered, corrected, and reconstructed so humans can perceive what our eyes were never designed to detect. This processing, though precise and scientific, can give the impression of direct, color-accurate sight. Sometimes people imagine Webb witnessing galaxies fully formed as if through a window, rather than piecing together signals that have traveled through expanding space, cosmic dust, and countless gravitational influences. That misconception can encourage the belief that Webb directly observed galaxies older than the universe, when in reality it simply captured ancient light that has been on a very long journey. Occasionally the confusion comes from mixing theoretical ideas with observational results, blending them together until they appear to contradict one another. Cosmology is filled with hypotheses, simulations, and mathematical possibilities, some speculative, some robust, some still growing into their shapes. When a discovery challenges a prediction, for example, galaxies forming earlier or faster than models expected, it does not break the cosmic timeline, it simply nudges theory toward refinement. But when someone reads both theory and observation without clear separation, it may seem like the observation breaks the model in a catastrophic way. In truth, science evolves through such tension, quietly tightening its explanations, not shattering them. Sensational headlines are another culprit, drifting in with the briskness of a gust that disrupts an otherwise still night. News outlets sometimes frame discoveries with phrases like rewrites the universe, smashes the laws of physics, or older than the Big Bang, not because the science demands such framing but because the drama attracts attention. And once a dramatic idea enters the public sphere, it spreads like ripples in a calm lake, easily creating echoes that distort the original message. Even when articles correct the claim within the body text, the headline may have already shaped the impression that something impossible has occurred. Even the vocabulary of cosmology itself carries seeds of confusion. Words like inflation, dark matter, dark energy, and cosmic microwave background sound familiar enough to imply simplicity, yet each represents deep, mathematically rich concepts that are easy to flatten into incorrect assumptions. Inflation, for example, is often mistaken for a slow swelling of space. Instead, it was a near-instantaneous exponential expansion. Dark matter is sometimes imagined as a substance hiding in shadows. In reality, it reveals itself only through gravitational effects. These misunderstandings are harmless at first but can create cascades of confusion when layered together with discussions about the age of galaxies, the timing of cosmic events, and the meaning of ancient light. A softer but persistent culprit is the human mind's natural desire to create a story with a single, clean timeline, a beginning, a sequence, a conclusion. The universe, however, does not narrate itself in such a straightforward manner. It began with an event that set rules but left room for complexities. Stars did not all form simultaneously, galaxies grew unevenly, black holes emerged faster in some regions than theory predicted. When people try to fit these irregularities into a strict storyline, paradoxes seem to appear, though they are only artifacts of trying to compress vast processes into a linear frame. The story becomes clearer when one allows for unevenness, for surprises, for the gentle messiness of cosmic evolution. Another contributor to confusion is the subtle distinction between age and formation time. A galaxy may appear extremely bright and massive for its early epoch, leading researchers to describe it as forming too early according to certain models. But forming early does not mean older than the universe. It simply means it organized itself faster than predicted. Without this distinction, people may imagine the galaxy's age as extending backward before the cosmic clock began, when in fact it merely condensed its material rapidly in the available window. This misunderstanding grows easily in the quiet gaps between scientific terms and intuitive language. Public excitement also plays a surprising role. When people feel awe, wonder, or fascination, their minds sometimes pull the discovery to the edge of impossibility to heighten the thrill. A galaxy that formed astonishingly early becomes, in the imagination, a galaxy from before anything existed. The leap is emotional rather than logical, born from enthusiasm rather than error. It's a small slip, like misremembering a dream as deeper than it was, and it spreads gently because it feels deliciously mysterious. Confusion can also arise from how often the universe's age is updated or refined as measurements improve. To the casual reader, these refinements may appear like uncertainty, and uncertainty may appear like contradiction. If one article says the universe is 13.77 billion years old and another suggests a slightly different figure, it can create a sense that the anchor point is shifting. And when the anchor point feels fluid, discoveries interpreted relative to that age can seem unstable, even paradoxical. Yet these refinements are extremely small adjustments at the edges, not sweeping changes that would ever allow something to predate the universe's beginning. A more subtle culprit lies in the difference between cosmic time and observer's time. The universe measures events by when they occurred in its own timeline, yet observers on Earth perceive those events through the time it takes their light to reach us. Mixing these timelines in conversation can easily create the illusion of contradiction. For example, saying that a galaxy formed 300 million years after the Big Bang while also describing its light as 13.5 billion years old can sound like two conflicting ages. In truth, both statements refer to different aspects, one to when the galaxy formed, the other to when its light began traveling toward us. But this layering can become confusing without patient explanation. Some confusion springs from the challenge of visualizing expanding space. People sometimes imagine galaxies flying outward through a static void, like sparks from a fire. In that picture, one might wonder how anything can recede faster than light or how distant light can still reach us. But space itself expands, stretching distances and wavelengths. The galaxies are not racing. The space between us is growing. Without grasping this, the entire structure of cosmic measurement can seem paradoxical, and misunderstandings about ages naturally follow. Another gentle culprit lies in the assumption that cosmic backgrounds, such as the cosmic microwave background, mean earliest possible light. The CMB is indeed ancient, but it is not the first moment photons existed. It is the first moment photons could travel freely without being scattered by ionized plasma. But to someone unfamiliar with that distinction, hearing that Webb has seen objects older than the background light can sound contradictory, even though the CMB's age marks transparency, not creation. Mathematical approximations also secretly create confusion. Cosmologists often use simplified numbers like 13.8 billion years to make explanations accessible. These rounded figures introduce tiny mismatches when compared with precise research papers. And because the universe's timeline is so vast, even a small rounding difference can cause someone to wonder how a galaxy observed at 13.5 billion years ago fits into a universe described as 13.8 billion years old. The misunderstanding is numerical rather than conceptual, but it feels significant if one doesn't realize the scale involved. Another contributor is the blending of peer-reviewed research with early, tentative claims posted as preprints. Preprints are essential for scientific communication but not yet vetted. When the public encounters a bold interpretation from a preprint and treats it as confirmed fact, confusion arises. And if later research revises or contradicts the initial claim, the earlier, more dramatic version often lingers in memory, creating the impression that scientists are unsure about the universe's age or Webb's capabilities. Science communication videos and social posts also play a role. Creators often condense complex ideas into compact, entertaining narratives, removing nuance to maintain attention. In this compression, subtle distinctions vanish, like the difference between unexpected galaxy formation rates and impossible chronological contradictions. And once the shorter version circulates widely, listeners may lose track of the original scientific precision. The wonder of cosmic scale itself is a culprit. The distances, the times, the speeds, the energies, they are so far beyond everyday experience that the mind seeks shortcuts. These shortcuts, though helpful for intuition, sometimes create the illusion that two ideas clash when in reality they operate on different layers of understanding. Trying to imagine billions of years with a brain evolved for human lifetimes is like trying to pour an ocean through a narrow funnel. Some spills, some transforms, and some becomes confusing. Even the phrasing Webb discovered something older than the Big Bang often begins as a metaphor for shock rather than a literal claim, a poetic way of expressing how surprising the findings seemed to scientists. But when metaphor is repeated often enough, it hardens into perceived fact. Without context, listeners may think scientists themselves made that claim, when in reality it was a dramatization introduced somewhere along the chain of retelling. Another gentle culprit is the tendency to treat the Big Bang as a single, simple start, like the moment a light switch is flipped. But cosmologically, the Big Bang describes a series of early conditions and transitions, not a single instant. Inflation, baryogenesis, nucleosynthesis, recombination each marks a different stage in the unfolding universe. When someone imagines the Big Bang as one pinpointed flash, anything observed close to that boundary feels like it challenges the boundary itself, even though the boundary was never as sharply defined as popular descriptions suggest. Misremembering plays a quiet part as well. A person might read a nuanced article, absorb most of it, but remember one dramatic phrase more vividly than the careful explanations around it. Over time, that single phrase, perhaps surprisingly old galaxy, transforms into older galaxy, then galaxy older than the Big Bang. The human mind simplifies, reshapes, and rearranges information in sleep and in conversation, producing small distortions that drift far from the original meaning. The stunning beauty of Webb's images also contributes in unexpected ways. When someone sees a galaxy rendered in vibrant colors, glowing with ancient brilliance, it can feel impossibly old simply because the colors signify depth and age emotionally. Even though the colors are assigned based on infrared data, the emotional response can override the literal explanation, leading one to imagine the galaxy's age in mythic terms rather than scientific ones. Language barriers also play a role. Scientific terminology translated into other languages may lose precision or gain unintended metaphorical shades. A term like earliest structures might become ancient structures or pre-universal structures depending on the phrasing. When translations circulate globally, small linguistic shifts can create surprisingly large conceptual misunderstandings. Cultural expectations of stories, beginnings, and mythic creations also influence interpretation. Many people carry mental archetypes of creation, stories in which something exists before the world begins. When cosmic discoveries align emotionally with these archetypes, the mind may subtly adjust the facts to fit the narrative framework, even without intending to. The result feels intuitively meaningful but scientifically inaccurate. Finally, the sheer volume of cosmic information, the expanding models, the adjustments, the revisions, the waves of new discoveries, creates an environment where misunderstandings naturally arise. Not through fault or neglect, but because the story is too vast for quick comprehension. In this immensity, gentle confusion blooms like dusk light over a quiet horizon, reminding us that learning the universe requires patience, softness, and the willingness to revisit ideas with renewed clarity.